Now, part of the cubic function is shown, okay? And it crosses the axis at 0, 6, and also crosses at a half 0, yeah? The easiest way to do this is that the f of x means y. Would you all be agreed with that? So the y value equals whatever x value you put in. Okay? And this is actually not too bad at all. Because the first x value we can put in is 0, and the y value has to be 6. Why does it keep doing that? Oh. Now, so here we go. What I'm going to do is I'm going to replace y with 6 and x with 0. And most people got this out. What does that mean about the q value? Q value is 6. You happy enough with that? Okay. Now, next thing I'm going to do is I'm going to replace the y value with, see the 0? And what do I have to replace the x value with then? Anybody? What are we going to replace it with? Half. Yeah, I'm going to replace it with a half. 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 And what do we get here then? 2 times an 8, which is a quarter. P over 4. What's it? Minus 11 over 2. And Q we know is 6. And it equals y value of 0, yeah? Now, can anybody put the 3 of these in the calculator for me? Save me a bit of time. What you get? Is it 0.75? Currently, it's 0.75, yeah? Then when I bring it out the other side, it's minus 3/4 equals P over 4, then P equals minus 3. Huh? Oh, sorry, green. Yes, keep reminding me. Yeah, it looks so dark on my screen, so I don't remember. But then when I put it on the board, it goes a different color. So you're right. Keep reminding me, because it's really dark on my screen, which is perfect. But then when I look up there, it's a different color. All right, we kill. Now, find the coordinates of A and B. Now I've got to rewrite the the equation here. What is it? It's going to be 2x cubed, yeah. 2x cubed, yeah. Px is minus 3x. What came after that then? At minus 11x. And then what's it plus q, is it? What's q? Q is 6, yeah? Now, if x equals a half is a root, what's a factor then? Yeah, but I have a different way of doing it. I do it as 2x equals 1, and then I saw some of you were dividing by fractions and you pulled it off. Fair play to you. Now, we are going to do this, aren't we? Now, I'm going to do a tribute to Nikita here. I'm going to show you the Nikita method again. Okay, would you agree that it's going to be a quadratic on top? Lad, you agree it's a quadratic on top? Here's the Nikita method. 2x minus 1 3 times. Because you have to multiply by the x squared, the x, and the regular number. The regular number is easy to find, because how do you turn minus 1 into plus 6? What do you multiply it by? First number found. Next one. How do you turn 2x into 2x cubed? Second number found. Okay? Now, if I just multiply this out, I get 2x cubed minus x squared. Now, I don't want minus x squared. I actually want minus 3x squared, which means there has to be another minus 2x squared lurking below. So what goes here to make that happen? And then I'm done. Long division achieved. What a man. Now, now guys, it wants the coordinates. Okay? So what we're claiming now is that we're claiming that this cubic that equals 0 is actually the exact same thing as 2x minus 1 into x squared minus x minus 6 equals 0. If we factorize this, which we have done, we get x equals a half, and we know that that point is a half 0, don't we? But we're going to have to factorize this, and what do we get? X minus 3 and then when we solve that, we're going to get 3 0 and minus 2 0. Cool? Okay. Okay. Explain why f of the function inverse doesn't exist. So first of all, it's a cubic function. Okay. Functions must be one-to-one or injective to have an inverse. That is itself a function. So I think that answer alone, just that first line will do it for you. The original cubic function doesn't have one-to-one correspondence, i.e. it's not injective. You could also say it's not bijective either, because bijective means you have to be injective and. So that would work as well. But that's the real reason, just right there. Okay, if you want the explanation, a function must map each input onto exactly one output. Similarly, the inverse function matches each output back to exactly one input. In the case of a cubic, this cannot be the case because inputs, the same output can have up to 3 different inputs. The end. All right, just the first couple of lines would have done that. Now, this one, I keep doing that. Now, this one hurt me. Right? Find the values for m for which the line y equals m, 3x minus m, and the curve have one point of intersection. Lads, it means the two curves intersect at the same time. So if this is curve A and that's curve B, it means they have a point where they have the same x value and the same y value. The y values are identical. Multiply that out and you get 3mx minus m squared. Most of you did this for 4 marks, to be fair to you. We won't put you down for that, all right? Now, what I'm going to do next is I'm going to move things across. I'm going to have 0 equals 4x squared. What else? What do you think? 4x squared, yeah? And then move over 3mx, so it's 5x minus 3mx. Would everybody be happy if I factorize that into 5 minus 3m times x? Would that be all right? I'm bringing the m squared over in a second. Just not fast enough for you. Okay. Now, I'm bringing over the m squared and it becomes plus m squared, yeah? Now, what are we thinking here? If it has only one answer, one point of intersection, not 2 points of intersection, you get what I'm saying? That must mean this quadratic has equal roots, which basically means that the plus or minus b squared minus 4ac must result in only one answer, which means b squared minus 4ac has to be 0. So therefore, we can say is b squared minus 4ac equals 0. A couple of these got this fully out, to be fair. Fair pages. B is 5 minus 3m squared minus 4 times 4 times m squared equals 0. 25 minus 30m plus 9m squared, 16m squared, minus 7m squared, minus 30m plus 25, multiplied by minus 1. I don't like dealing with negative quadratics. And we could solve that, and you get 2 answers, and your answers are m equals 5 over 7 and m equals minus 5. We cool?